Hello, everyone, and welcome to BCC Research's fourth webinar in our AI webinar series, AI and the Future of Data Centers. I'm Ryan Brothel. I'm the Director of Marketing here at BCC Research and your host for today. Over the last year, we have seen AI reshape compute demand at a speed the industry has never experienced before. And that escalation is putting massive pressure on data center infrastructure, cooling, power availability, and sustainability. To unpack all of this, we're joined by two fantastic experts today. First up, we have Greg Johnson, who's the Associate Director of Consulting at BCC Research. And today, Greg is joined by Liz Cruz, who's the Chief Marketing Officer at Celsius, a leader in advanced cooling solutions and a member of the NVIDIA Inception program. Thank you both for being here today.
My pleasure.
Good to be here.
Right. Before we begin the official discussion, can I please ask you to leave any questions you have for our panelists in the chat, which we will answer at the end of the session as part of a Q&A session. There will also be a short poll during the webinar, which will offer some interesting insights around AI and data center deployments. Much of today's discussion will also be discussed in more detail in our upcoming AI and data center reports, so please do reach out to us if you're interested in learning more. With that bit of housekeeping done, let's jump straight into the discussion. First up, a question for you, Greg. Greg, BCC Research's upcoming findings show that hyperscalers spent nearly $300 billion in 2025 to expand AI capacity. What's driving this urgency, and how is this enormous level of investment reshaping infrastructure planning as we move towards 2026?
Yeah, I mean, that's a massive level of investment. I was trying to think of a parallel for this that we're seeing, and in many ways, it reminded me of the space race back in the 1960s and 70s, right? So at that point, you had very high stakes, very geopolitically charged competition. You had massive capital spending, rapid innovation, and ultimately the belief that whoever leads the race will shape the next era of global power. So, many parallels to take away there. However, one key major difference here is this time around, we actually have corporations leading the charge rather than federal governments. Ultimately, the urgency is driven primarily by the explosive demand for advanced generative AI as well as large language models. You've got, those two key factors, along with the major commercial and financial incentives tied to that demand. When we look at top hyperscalers like your Amazons, Microsofts, Apple, Meta, Alphabet, or Google, better known as Google, we're seeing widespread investment across the sector, really specialized around compute resources, as well as ensuring that they have the equipment that they need to build out these data centers, as far as power gen, water, cooling, etc. All the various technologies that go into building out these data centers. When we look at some of the work BCC has done recently, we've estimated the global data center market to be just under $400 billion in 2024. We're projecting double-digit growth over the next 5 years, reaching approximately $691 billion by 2030. So, obviously the hyperscalers are leading the way for this growth. And it really is their ability to escalate and handle these massive, fast-growing, both AI and cloud workloads. So, with this large investment, we're seeing the market kind of reshaping infrastructure planning with a focus towards rapid scalability, vertical integration, as well as deployment of custom silicon chips.
Perfect, thank you. I'm glad you touched on the topic of planning there, because obviously the surge in investments is also happening at the same time as major supply constraints, especially around high-performance AI accelerators. And I think it's fair to say NVIDIA's dominance is also kind of creating real pressure across the ecosystem. How is this influencing deployment timelines, capacity planning, and even the physical design requirements of new data centers?
Yeah, so I mean, obviously, NVIDIA's the 500-pound gorilla in the room with a large market share, I think estimated between 70 and 80% for the AI accelerator chips. We're seeing increased competition from others, such as AMD's Instinct accelerators, Intel's Gaudi 3 accelerators, as well as Google's Tensor processing units or TPUs. So these new entrants are offering promising alternatives to NVIDIA. However, their current impact remains somewhat limited because adoption is still at early stages. Um, I guess some of the other dynamics going on here with NVIDIA's large share, they have substantial leverage over both the supply as well as impact on pricing that has. So it's really kind of forcing hyperscalers to focus and rethink their timelines around capacity planning. When they'll actually have access to this critical hardware and to try and get around some of the bottlenecks. Beyond just the bottlenecks with the compute hardware, BCC has also been tracking numerous other equipment markets. So, for example, over the past several years, we've tracked the diesel generators market, which are used for backup power in these data centers. Many of the hyperscalers are looking to expand the suppliers for these diesel generators, simply because presently there's only a handful of global suppliers that can manufacture these generators to the size, scale, and requirements that data centers need. So in that market specifically, we've looked at or we've seen a 40 to 50% year-on-year growth in that market for those products, longer lead times, rising prices, and ultimately that's just one piece of equipment, one market, right? So if you kind of multiply that impact across numerous other equipment markets, such as networking hardware, switchgear, battery systems, UPS, and even cooling systems, which Liz will get into here shortly, you can really kind of begin to see the massive scale and challenges that the market's facing, as well as data center construction companies trying to keep pace with this massive build up.
Perfect. I think I am going to directly lead into that. Those cooling challenges, Liz, if you don't mind. So Greg just highlighted how hardware bottlenecks and extremely dense GPU clusters are kind of shaping facility design. From Excelsius's perspective, as these AI-heavy clusters become the industry norm, what new thermal and operational challenges are operators running into? And then I guess, what does the new normal look like for cooling AI workloads in 2026?
Yeah, absolutely. There's definitely a lot of innovation required in this space. And I don't think that there is a new normal yet. I think that we're all in a new era of trying to understand what AI data centers need for their infrastructure. We've done, decades of air cooling, and now with chips, well over 1,000 watts per chip, we have to move to liquid. So in terms of the thermal challenges, the chips are just too hot that they do demand a new technology. And the operational challenges that brings along with it is really learning how you're going to implement liquid cooling in your data center and what are the different types of liquid cooling. And along those same lines, when operators are evaluating the different technologies, there's a bigger and bigger recognition that servicing and maintenance of different liquid cooling technologies is very different than what it was for air. So there's a whole industry that's needing to learn how to service this new the poll just popped up. How to service this new technology in the data center. So a lot of education happening, which is how a lot of our customers come to us, is really trying to learn at first, okay, I'm buying this next generation of chips. What does that mean for cooling? And so we work through that with them. So there's a big learning curve. And the hard part of this is for everyone is that this is a learning curve on a technology that's probably the most expensive thing that's ever been brought into a data center. I shipping at, $50,000 a chip, $500,000 per server. Everyone wants to make sure that they make the right choice for the next decade or more, and that they're making a choice that fits in with their existing operational procedures, really. So I don't think the normal is defined yet, but I do think a lot of people in the industry across, in our sector in cooling, our leaders work a lot with ASHRAE, with OCP to define those new standards. And also, with government organizations and projects, we're working with the ARPA-E on the Cooler Chips project to just really benchmark and evaluate what normal should look like.
Perfect. Thank you. It's a great answer. Just obviously, there's not everyone's directly involved in the cooling process. Could you break down the key differences between these approaches when it comes to like air cooling, liquid cooling, cold plates, and where each solution tends to make the most sense in modern AI environments?
Yeah, absolutely. So there's really four different types of liquid cooling. And there's obviously also air, which everyone is very familiar with. But when you start to look at these higher TDP chips, it's really liquid cooling that's the solution. And so there's really four categories. There's immersion, single phase, and two phase. And then there's direct to chip, single phase, and two phase. An immersion is kind of that bathtub form factor where you're dipping a server into fluid. Single phase obviously maintains its liquid state, two phase changes, and there's an improvement in the density that you can do with two phase immersion versus single phase. Immersion, because of the nature of really dipping a server into the tank, is very different. It's talking back about those operating procedures. It requires a lot of changes to the way you build a data center, to the way you service it. So immersion over the last couple of years has seemed to fall out of favor. There's definitely still applications for it, maybe some edge applications, definitely in crypto. There's still use cases there. But the one that you see, the technology that you'll see most frequently, especially if you go to any of these AI shows or data center shows, is direct to chip. And so there's single phase and two phase varieties of that. But direct to chip is where you see the components that you mentioned, cold plates, manifolds, et cetera. And so what that is, it's a cold plate sitting on top of most of the time, GPU that has a fluid flowing through it that removes the heat in that manner. In a single phase solution, it's flowing in as a liquid and coming out as a liquid. In two phase, it flows in, nucleates on the chip, and comes out as a vapor. That two-phase solution, which is what Excelsius does, is able to remove a lot more heat simply because a phase change takes a lot of energy to change phases, and so it pulls a lot of heat from its nearby surroundings. So two-phase direct-to-chip does have superior heat removal, but it is a newer technology. We've been around 3 years. Single phase direct to chip, you may see companies like CoolIT who have been around for a couple decades now, and really just hitting the demand point of this piece. But it's what you may see a little more often. But going forward, as chip densities and the heat increases, there's really a movement, and we've already started to see that tipping point to two phase. And one of the other benefits besides the superior heat removal for two phase is simply the fact that single phase solutions use a water mixture. So the fluid that's flowing through the server is a water propylene glycol mixture, and we all know water and electronics don't mix. And so as more have been deployed, there's been more cases of leaks and damage to GPUs, these very expensive components that we've just talked about. So the avoidance of damage to GPUs has drawn attention to two phase, which uses a refrigerant, which is non-conductive dielectric, and poses no risk. And then the last piece that I'll mention that is a larger consideration factor is the maintenance and servicing on a system that has water flowing through it, because there's biofouling concerns. And so there's a lot of maintenance and check-ins that need to happen with a single phase solution that don't with a refrigerant solution, just like you don't have to maintain those loops in your house or in the other many applications where you find and use refrigerants. So those are kind of the key differences. And we have lots of materials if anyone wants to dive deeper.
Perfect. Thanks for that. I think as you touched on all those different cooling options, as Greg mentioned, the 500-pound gorilla in the room is that the vast majority of chips that you're cooling are owned by NVIDIA. So obviously Excelsius is part of the NVIDIA Inception program, which supports innovation in advanced AI infrastructure. How has being part of that program shaped your technology developments, and what advantages does it give you regarding GPU architecture and the evolving thermal requirements intensify?
Yeah, absolutely. I think you're right. It's the gorilla in the room, and if you're not working with or building for NVIDIA, then what are you doing? Yes, we were invited into this Inception program earlier this year, and I think more than anything, it shows two things. One, it shows that NVIDIA is really smart at building an ecosystem for their products, in terms of for future generations, they're going to need two-phase cooling. And so they're ensuring that companies that provide that are in the loop, in the fold. Just in the same way they taught every, developer to code in CUDA so that there was a market for them. They're smart about building for the ecosystem. So that invitation is a huge testament to where we believe, and it's starting to look like the market is going. Um, Also, just being deeply involved in working with the leading chip manufacturers is key. I mean, when you mentioned the new normal, I was thinking about like the minute you think you understand something, NVIDIA comes out with something new and you've got to learn again. So these innovations on the AI hardware side are at a breakneck speed. And so we, as someone who's supporting those innovations, need to also be in the know of what's coming, but then also able to react. And so, working with companies like NVIDIA, we have a really strong team of thermal scientists that have to respond quickly and innovate quickly to meet all the innovation that's happening on the AI side. So, I think that program and us being a part of it is just another way where we really need to be working together and quickly with the smartest minds. We also, like I mentioned earlier, are very active in OCP and ASHRAE. This is an industry that's changing fast, so people need to come together, support each other, and come up with solutions that work together. So we're
100%.
really excited to be a part of that. Yeah.
Awesome. Thank you. It's another great answer. Before getting on to you, Greg, I do just want to quickly remind everyone that we are running a Q&A session at the end, as well as a series of polls. So if you do have any questions for Liz and Greg, please shoot them into the chat and we'll address them at the end. A couple of things again, it feels like this kind of cloud that's hovering. I don't want to use the bubble word, but it is things have moved quickly. So on that note, Greg, there's obviously this issue of capital risk and monetization pressure because all of these businesses have kind of funneled all of this money into AI very, very quickly. And obviously, this cooling and infrastructure upgrades come with significant cost implications. So, as an example, BCC Research found a 112% spike in data center debt issuance in 2025, including large SPVs used by hyperscalers. How concerned should the industry be about the pace of this debt-driven infrastructure expansion? And I guess, is it sustainable?
I think there's definitely some potential significant concerns with with the rising debt that we're seeing. Hyperscalers are increasingly relying on SVPs, which are special purpose vehicles. And then ultimately, what these are is a way for these large companies to keep their finance and their debt off their core balance sheets. So, I think. Back when I think to my past life as a in finance and lending back before I became a research analyst and consultant decades ago, we saw the 2008 financial crisis and bubble with housing. Certainly I don't think we're anywhere close to AI and data center debt and build out being anywhere on the same scale of something like that, but for sure it's something that companies need to monitor and take a balanced approach. Some of the risks that we're seeing inherently in the market is really just the sheer speed that the GPU technology becomes outdated. So, for example, with many of the new chips coming out, they're really only being used in peak production for 18 to 24 months before they need to be utilized for other purposes. And there's rapid technology change that are that quickly kind of change the investment dynamics. I kind of also think back to the California gold rush, right? So, and in a lot of ways, this AI boom is very similar. You'll see many new entrants, many new companies rush in to try to fill the gaps in supply and demand, and service this market. Ultimately, some folks will kind of hit it rich, and others will lose their shirt. So, I think the companies that can most responsibly manage their debt, and also obviously having winning technology, those companies are going to see the longer term success.
Perfect. I'm going to ask you to expand on that a little bit. Obviously, the research shows that AI investments can create huge productivity gains in sectors like the automotive sector, the media sector, biotech, research. I think everything at the moment feels like if you use AI, you'll see productivity gains. I suppose the question is, are these returns becoming broad enough to justify the scale of spending we're seeing? Or they're still too concentrated among a few early adopters?
I think it's still kind of case by case. So, I'll cover some examples here shortly. Some wins that we've seen. So, ultimately it's about kind of producing um, that kind of dramatic, quantifiable productivity gains that companies are looking for. And we're seeing that across multiple industries. So one example is with a company called Continental. They're a very large automotive manufacturer. They were able to already see a 70% reduction in their AI training time for their advanced driver assistance system. So with this improvement, and it enabled them to have 14 times more deep learning experiments per month, as they're training that driver assistance software. Um, if we shift gears and look at the companies like Walmart in the retail space, they've already begun to roll out AI across their global supply chain, um, essentially re-engineering their supply chain with AI built in. So this has allowed them to forecast product demand across their stores, improve routing and delivery, as well as optimize their inventory um, uh, at their local uh, factories. Uh, Beyond this, I think they've said a press release stating that they've already seen efficiency gains across more than 5,000 of their stores. So that's already paying massive dividends on that investment. Um, as some of the audience is aware, BCC is heavily involved in the academia and research side of things. So, with some of our connections over there, we've seen, uh, for example, the University of Birmingham. They invested heavily in high performance storage to support their accelerated data processing and analysis capabilities for their researchers. So, really, in an example like that, the data AI investment is giving the researchers, much better ability to conduct research, and ultimately that we may not see the returns on that for 10, 20 years, because those things need to be commercialized. But there is real tangible impacts to that investment coming down the road. Um, so yeah, I think it's, while industry leaders are currently seeing the biggest return on investment, that there is a broader shift and trend towards more widespread impact. As the AI technology matures, and as there's more penetration where AI is really involved at a fundamental level across organizations worldwide.
Awesome. Thanks for that, Greg. And thanks for those examples. I think it's also kind of important to highlight that when people hear AI, they immediately think, oh, these people are using ChatGPT or Claude or one of the other big LLMs. But increasingly, that's not necessarily the case. And another trend highlighted in BCC researchers' work is the move toward distributed and domain-specific AI architectures. How is this shift changing the way data centers are designed, and how will it influence where compute gets deployed going forward?
Yeah, and we've really seen a clear shift from your traditional centralized cloud data centers more to a distributed or domain-specific AI architecture. So kind of the need behind this shift is really the ability to support real-time, low latency applications and address data privacy concerns that many companies have. That security is a growing concern, certainly. Um, and I think some of the other things our analyst team have highlighted here is as the hyperscalers are investing in custom silicon, the standard or more generic hardware can no longer meet the current demands of advanced AI workloads. Some of the other things that we're tracking is as it relates to edge compute. So edge compute has been something that's been around in manufacturing it's a growing trend in manufacturing for many years now. Um, and actually the ability to incorporate AI into the edge compute is kind of a newer dynamic that's really exciting. Just a few weeks back, I was at the Rockwell Automation Fair. I got to see Cisco's unified edge platform in action there. So it's really really promising new technology that allows you know it allows AI to actually have that AI compute power at the edge or at the factory floor level, and I think it'll be a potentially a huge step forward for the manufacturing industry.
Awesome. Thanks for that, Greg. Before we move on, I do just want to quickly remind everyone that we are taking questions. If you want to put them into the chat, we will answer them at the end. As you will have just seen, another poll has just been launched, which we're running throughout the webinar, just to give us some insights and some information about our attendees today and where things are heading. I think one of the questions that needs to be asked following this distribution question, Liz, is sustainability. And I think it's something that's kind of, with all this investment that's gone up, is a key factor in a lot of people's minds. So Greg's points about distributed AI ties directly into sustainability pressures. Obviously, power availability and water consumption are becoming major constraints for AI data center expansion. From Excelsius's perspective, how serious are these concerns heading into 2026? And what innovations are emerging to help operators scale responsibly while dealing with resource limitations?
Yeah, absolutely. I think they're very serious concerns, and we should be worried, and we should be looking at it. Looking at the poll, rising global power demand. I mean, it's highly concerning given the forecasts for AI adoption. So if we are going to meet that AI demand, I mean, we have to radically change the way that we build data centers. And so there are many initiatives. I mentioned the ARPA-E Cooler Chips program earlier. Just last week, or maybe 2 weeks ago, there was legislation proposed, a bipartisan bill to look at liquid cooling technologies to reduce energy consumption for AI data centers. And it's kind of a proposal with two parts. One is what Greg was mentioning earlier in terms of the space race. I mean, we want, well, I realize this is a global one, but every country wants to be a leader in this space. And in order to have that economic growth, you really need to build data centers, which have a energy strain. So to find that balance, you really do need to look to technology innovations to reduce the power grid demands. And then you also mentioned water. So in terms of what you can do, I mean, I think, that's why you're asking me. Liquid cooling really is a significant impact on energy use in a data center. 40% of a data center's energy use roughly goes to cooling. So it's looking at cooling makes a lot of sense when you're trying to reduce that. And our technology can reduce that energy use by 60 to 65%. So that's huge in terms of power savings. And you did mention also the water usage fact, which is a concern, and it's a struggle because it's a trade-off. Sometimes the technologies that use less water are the technologies that tend to use a little bit more energy as well. But I do think there's been a lot of improvements on that side in terms of the final heat rejection. I mean, there was the number, it was like 2023 or 2024 when Microsoft said that they had used 34% more water year over year, and it was due to AI workloads. But that was legacy infrastructure. It was some swamp cooler, evaporative cooling technology, which is really the big water user. So there's new innovations in terms of the final heat rejection, more efficient chillers that require less water usage. Also, the more efficient you are in the white space, the more efficient you can be with the final heat rejection. So, for example, liquid cooling, our technology, we're able to use a lot warmer inlet water temperatures. So you can take advantage of free cooling more often, which means you're not using the water usage there as well. I think it's a huge concern. I think that there's some important initiatives, a few that I mentioned just in, here in the US, there's in Europe, a lot more aggressive initiatives to make sure that we are building sustainably. And I do think it's, as an industry, our responsibility to put the best foot forward so that we can continue to build and meet demand.
Awesome. Thank you. It's another great answer. Something that Liz kind of touched on there, Greg, is that this is not just a US thing. It's not just a Europe thing. It's not just a China thing.
Right.
It's very much a global AI infrastructure race. So to kind of bring it all together, I know BCC research shows that North America is leading revenue at the moment. APAC is growing the fastest, and Europe is kind of pushing hard for sovereignty and driving regulations. How do you see these different regional dynamics evolving in the coming year? And are we heading towards a true global AI infrastructure race?
Yeah, I think we're already seeing aspects of that currently. So I mean, the regional dynamics we see, we fully expect them to continue to intensify through 2026 and the coming years. Each region will kind of pursue their own strategies and goals there, aligned with their unique capabilities, priorities, and competitive advantages. Obviously North America remains the leader in global AI build out. All the top hyperscalers and cloud providers are for the most part based here, as well as North America has a robust ecosystem and supporting host of supporting players. Ultimately, where we're really seeing where we expect to see the fastest growth is going to be Asia Pacific. So we're estimating roughly 22 to 25% CAGR in that region over the next 5 years. Highly driven by growth in China and India, as well as the national AI policies and very large investments in those countries. Europe is accelerating, but also, as you mentioned, pushing for more of a technological sovereignty. So they have a few initiatives. One's called AI Continent Action Plan, and the other's Invest AI. And both of those aim to build out regional AI factories and reduce further reliance on foreign technology. Similar to energy independence. Talking point that's often politically pushed here. I think here in the U.S., AI is now becoming a political hot button topic around the world. And then if I think here locally, specifically I'm based in Texas, we've seen massive announced investment. There's the Stargate project. So, that's basically a new company funded by OpenAI, Oracle, and SoftBank. They're looking to invest 100 billion immediately, with plans over the next 4 or 5 years to actually reach 500 billion in investment. So that's building out new data centers, AI infrastructure, along with their flagship data center based here in Abilene, Texas. So yeah, everyone's getting into the race, and it'll be really interesting to see kind of which regions win and which regions lag behind somewhat.
Awesome. Thanks, Greg. That leaves us for our main questions, although we have got a bunch of questions in chat. And one of the ones actually specifically talks about the different regions for data centers. So I'll ask this one to you, Liz, if you don't mind. Greg brought up Texas. I can't say I've been to Texas, but one thing I do know is it gets very, very warm. Um, what are your thoughts on data centers being funded and hosted in these warmer regions and possibly even in the Middle East nations? How are the cooling needs in these deserts being addressed, and what is the cooling strategy there? Are there different factors that need to be introduced? And are there possibly even data security issues that need to be considered when considering different regional centers?
Yeah, that's a very interesting question. There's a lot to balance, I'm sure, when they're looking at these projects in terms of tax advantages, cost of land, where does cooling and water usage really fall on the priorities when they're picking the site. So that's an interesting question. We actually just did a reference design with Jacobs Engineering to evaluate, and I can speak specifically to liquid cooling, to evaluate a single phase liquid cooling deployment and a two-phase liquid cooling deployment across many regions, one of which was Austin, Texas. And there's still the potential to have very low PUEs using the right technologies in the right regions. We have a number of customers in the Middle East region that are looking at our technology for those very same reasons. In order to get energy costs down and to be able to get the performance they need out of chips, you do need to look at different cooling innovations and technology. So, for example, with us in Austin, we're still able to significantly reduce the average PUE of a data center. And even just compared to single phase liquid cooling, we reduced energy usage by 30 to 35%. So to answer your question, I think when you do pick these warmer regions, you do need to evaluate other cooling technologies than air.
Awesome. Thank you. I have another question here. I'll ask this one to you, Greg, if you don't mind. It seems like a lot of the infrastructure developed at the moment is towards what people would call compute factories. They are very AI centric, and they're not necessarily being built on top of the existing data centers. So looking forward, particularly from an architecture and planning point of view, do you see there being more overlap between these traditional hyperscalers and these compute factories? Can they exist and be complementary to each other, or are they two completely different pieces of architecture?
I think they're different enough, and more of what our analyst team has been saying is probably more the specialization, right? So, um, yeah, I mean, historically, the large, let's say, cloud focused data centers, um, that technology is well, it's not it's not out of date from a operational standpoint. From a cutting edge compute power standpoint, it somewhat is. So I think ultimately we'll continue to see specialization and focus on specific applications where these AI compute centers or they'll be able to offer potential different services and applications to their client base. But yeah, I don't necessarily foresee a large shift back to kind of combining those two.
Got it. Liz, there's a somewhat technical question here. I hope you don't mind, but it does play into the infrastructure point of view. We're hearing a lot of moments about the 60 to 100 kilowatt per rack becoming common for AI clusters. How quickly do you think operators will need to design for 150 kilowatts or higher? And is there a tipping point from switching from air to liquid, or should people be already looking at liquid now?
Yeah, I think it's funny that 60 to 100 seems low for the inquiries that we've been getting. And I do think, just in the time in the last 3 to 4 years, the requirements are like doubling in some cases year over year. So absolutely don't build for what you need today, build for as there's a lot of talk about 600 kilowatt per rack now too from NVIDIA, and even up to a megawatt per rack. So absolutely, I think build for the future. And then yes, I think there are cases of rear door heat exchangers being able to do 70, maybe 75 kilowatts per rack, which is kind of the last band-aid for air. But once you get above that, I really think the only choice becomes liquid.
Perfect, thank you. Greg, there's another interesting one here, which I think is also quite prescient. With GPU availability still being constrained, are we seeing more operators diversifying into AMD, Intel, or other specialized accelerators, or is NVIDIA's ecosystem still too dominant to shift away from?
I think we're starting to see the early stage of a shift, right? There's definite appetite there to I mean, and it goes with any market, right? Anytime you have a dominant player like an NVIDIA with, 70 plus 80-ish% market share, you're always going to have other entrants enter and try to pull away that market share over time. So yeah, I think there's a lot of other companies out there trying to compete with NVIDIA with their own chips, own custom designed silicon, as I mentioned earlier in the talk. Um, I don't think we've yet seen the full impact and adoption of that shift. So it's still kind of early days. NVIDIA is still kind of propping up the market right now.
The 500-pound gorilla in the room, for sure.
Yep.
Liz, it's quite an interesting question here, although maybe a bit of a simple one. But data centers are quite large developments. They're not just small buildings, they're massive warehouses at times. So, what is the conversation like between when choosing a location between the stakeholders and you as a cooling provider and like local governments? Or what are the conversations like? What are some of the factors you have to take into account? Things you have, tick boxes you have to check, that kind of thing.
Yeah, you're right. It is a tremendous collaboration of so many stakeholders, and we were just going through this morning kind of what does that look like? What boxes do you need to check? And it's a lot, and it's very circular. It's inputs to one, outputs back to another. So I do think that it is a lot for an operator to take on, and that's why there are consolidation efforts in the industry where, for example, JCI just made a strategic investment in us. And so that's really an effort to offer a more comprehensive thermal chain. So it's, we cover from the chip and they cover out to ambient air. So then you have kind of one partnership, at least, that can drive a total thermal solution. And you see a lot of M&A, and I'm sure Greg tracks this closely, a lot of M&A activity in the space, and a lot of it is aimed at trying to simplify all these many pieces that have to come together. One thing that you mentioned, local government, I do think, and we hear about that, I think it was like $64 billion was held up in data center builds due to protests and community pushback. So I do think it's kind of on our industry as the data center sector to ensure that we are demonstrating thoughtfulness to where we're building and how we're building to gain that community buy-in. And I think some of the things we talked about earlier in terms of the legislation that's being proposed and the different programs to aid in building more sustainably will help gain that community acceptance and then, allow for one of the blockers to be removed. But it's a good point. There's a lot of hands in this pot and when you're building a data center. So important to align stakeholders.
Awesome, thank you. That's super interesting. Right, one question, but I am going to ask it to both of you. I'm going to stick with you, Liz, if you don't mind. If you have to recommend one or two strategic priorities for operators preparing for 2026 demand, whether that be cooling, technology, siting, capacity planning, etc., what would they be?
Just because it's the last thing we were talking about, I would absolutely say one, yes, look at the cooling technologies and begin the education now. I do think things are changing so fast, and we're all honest that this is new to all of us. So the sooner you can start learning, educating, going to shows, reading different white papers, just trying to familiarize yourself with the different technologies that are out there, that's really key. And then I do think that on behalf of, everyone in the industry, it does help to consider the different ways we can communicate what our industry is doing in terms of building for AI and what that means, what the benefits are, what the drawbacks are, and what initiatives each company and stakeholder is taking to reduce the stress on an environment.
Awesome, thank you. I'm going to be a little bit cheeky. I said it was the last question, but Greg, I have one more question for Liz, and I'm going to give it to her because it's from her CTO, Richard, and I think it's very interesting. Um, Liz, can you comment on the importance of partnerships from a power, cooling, and facility perspective required to address AI factories and 1 megawatt racks?
Yes, absolutely. I think we do bringing dealing with hotter chips means that you also need to power those chips that are driving or running these AI factories. So we have worked with a lot of different partners to ensure that when we're delivering this unique cooling solution, that the power requirements for bus bar, for rack PDU also fit into the space, quite literally fit into the space, and then are compatible with one another. So we've worked with Harding on some education pieces talking about what it means to not just cool, but also power these massive racks. So I do think it's another piece where partnerships are required.
Awesome. Thank you for that. Right, Greg, promise last question. It is the same one that I asked Liz a question ago. Um, if you have to recommend one or two strategic priorities for operators preparing for 2026, cooling, technology, siting, capacity planning, whatever that may be, what would they be? What would you recommend?
I And so in working with some of our clients, what they tend to run into is competing timelines. So with building a data center, you have massive um, let's say bottlenecks across equipment and technology, siting and planning. So it's ultimately, I think, the ones that can best optimize their kind of overall project planning and procurement to make sure that they're getting the equipment delivered on site, when it needs to go in, that there's not multiple month delays just because they're waiting on one small piece to finish the build out. Um, yeah, I'd probably say just juggling all the spinning plates of um, you know uh, vendors, equipment manufacturers, um, construction, and yeah, that's probably seems to be the biggest challenge I've seen from talking to our clients.
Awesome. Thanks, Greg. Thanks for that insightful answer. And thank you to you both, Greg and Liz, for the depth and clarity you brought to today's discussion. Also, thanks to everyone who joined us for this live session. Again, I would like to remind everyone that we do have an upcoming AI and infrastructure report, which will be published in the coming weeks. If you are a subscriber to BCC Research, you already have access to this report when it comes out. If not, please reach out to us and we'd be happy to share it, as well as any other questions you have about today's session. I again would like to extend my thanks to Liz, Greg, and the rest of the BCC Research team, Ria, Dibia. Thank you very much. And everyone else, please enjoy the rest of your day.